Math 1108, Section 7.6, Solve Rational Inequalities. Solve each rational inequality, write the solutions in interval notation. When solving a rational inequality, we want one side to be 0, which we already have, and then we want to find the endpoints of the intervals. Those are determined by the x values that make the numerator 0 and combined with the x values that make the denominator 0. So we can tell just by looking what the endpoints are. The endpoints are the endpoints of intervals, and we're going to test each of the intervals. One of the endpoints is x equals -2. That's the x value that makes the numerator 0. The other endpoint is x equals 3. It makes the denominator 0. So we draw a number line, and then we plot the endpoints. -2 is to the left of 3. And so those two endpoints divide the number line into 3 separate intervals. And we're going to pick a test point from each interval. For the interval on the left, I'll pick x to be -3. And what we do with our test point in the inequality, replace every x with the test point. If the resulting inequality is true, it means the entire interval from which the test point came is part of the solution set. But on the other hand, if the resulting inequality is false, then that means that the entire interval from which the test point came is not part of the solution. Okay, so our first test point from the interval on the left between -∞ and -2 is x equals -3. Replace every x with -3. In the numerator, -3 plus 2 is -1. In the denominator, -3 minus 3 is -6. And -1 divided by -6 is positive 1/6. And the inequality greater than or equal to 0, that's true. So that means all of the numbers in the interval from -∞ to -2 are solutions. In the second interval, we can pick any number we want between -2 and 3, but since 0 is in that interval, that is often a convenient number to pick. And then replace every x with 0. In the numerator, 2, 0 plus 2 is 2. In the denominator, 0 minus 3 is -3. And this number is negative, but the inequality is greater than or equal to 0, and that's false. So none of the numbers between -2 and 3 are solutions. Then in the third interval, between 3 and infinity, pick any number you want greater than 3. I'll pick x to be 4. And when you replace every x with 4, in the numerator, 4 plus 2 is 6. In the denominator, 4 minus 3 is 1. And 6 over 1 is positive, and a positive number greater than or equal to 0 is true. So that means in the interval from 3 to infinity, we have another solution, part of the solution set. We have to determine if the endpoints are included or excluded. In general, any endpoint that comes from a denominator is never included in the solution set because division by 0 is undefined. And then endpoints that come from the numerator may or may not be in the solution set. It depends on what kind of inequality we have. So in this example, we'll test the endpoints. Test the endpoints. So the endpoint that comes from the numerator is -2. So replace every x in the inequality with -2. In the numerator, -2 plus 2 is 0. In the denominator, -2 minus 3 is -5. But 0 divided by -5 is just 0, and then the inequality is greater than or equal to 0. Well, that's true because of the or equal to 0 part. The other endpoint, x equals 3, replace every x in the inequality with 3. In the numerator, 3 plus 2 is 5. In the denominator, 3 minus 3 is 0. But remember that division by 0 is undefined, so that means we exclude the endpoint that comes from the denominator. Okay, so in this case, we're including the endpoint that comes from the numerator. So graphically, we would put a bracket there at -2. We're excluding 3, so graphically, we would put a parenthesis at the endpoint that we're excluding and then shade in the other part. The interval notation for this this rational inequality, well, I ran out of room here, so I'll write it at the top. The interval notation for this is -∞, comma, -2 bracket, and then union parenthesis 3, comma, infinity. Okay, in the next example, number 2, in this one we have x plus 5 divided by x plus 2 is less than 0. Once again, we have 0 on one side. We always want 0 on one side. And then the endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So once again, we can tell by looking what the endpoints are. The x value that makes the numerator 0 is -5. The x value that makes the denominator 0 is -2. And so we'll draw a number line again and plot the endpoints. -5 is to the left of -2. Those divide the number line into 3 separate intervals, and we want to find the intervals that are solutions to that inequality. In the interval on the left, the interval that's between -∞ and -5, I'll pick -6, and then in the inequality, I will replace every x with -6. In the numerator, -6 plus 5 is -1. In the denominator, -6 plus 2 is -4. -1 divided by -4 is positive 1/4, but the inequality is less than 0. 1/4 less than 0 is false. So no number in that interval between -∞ and -5 is a solution. In the second interval, I'll pick x to be -3. And then in the inequality, replace every x with -3. In the numerator, -3 plus 5 is 2. In the denominator, -3 plus 2 is -1. And so this number is negative. A negative number less than 0 is true. So every number in the interval between or from -5 to -2 is part of the solution set. And then in the third interval on the right, I'll pick x to be 0. In the inequality, replace every x with 0. In the numerator, 0 plus 5 is 5. In the denominator, 0 plus 2 is 2. A positive number less than 0 is false. So none of the numbers in the interval from -2 to infinity are solutions. Remember that we always exclude endpoints that come from the denominator. So -2 is not part of the solution set. So graphically, we put a parenthesis there. The other endpoint, -5, is also excluded in this case. If you were to test the endpoint, replace every x with -5, you would get 0 divided by -3, but that's just 0, but 0 less than 0 is false, so we exclude this endpoint this time. So we put another parenthesis at -5, and then we shade the interval that is the solution set. The interval notation for this is parenthesis -5, comma, -2. The parenthesis on each end indicates that the endpoints are not part of the solution set. And the next example, number 3, well, we have 0 on one side. That's what we want. And then we want to find the endpoints. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So I'll rewrite this inequality with the denominator factored. It factors pretty nicely. X plus 2 and x plus 1 are the factors of the denominator, and the inequality is less than or equal to 0. So the endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. The x value that makes the numerator 0 is 4. one of the x values that makes the denominator 0 is -2, and another x value that makes the denominator 0 is -1. So those three numbers are the endpoints of the intervals, so we'll draw the number line and plot the endpoints. -2 is to the left of -1, which is to the left of 4. Those three endpoints divide the number line into 4 intervals this time. And we're going to pick a test point from each interval. In the interval on the left, I'll pick x to be -3, and then replace every x with -3. We can use either the factored form of the denominator or the original. It doesn't matter, but let's just do the original. In the x value in the numerator, -3 minus 4 is -7. And in the denominator, the number -3 squared is 9, plus 3 times -3 is -9. So 9 plus -9 is 0, and then plus 2. So we get -7/2 less than or equal to 0. That's true. So the numbers in the interval from -infinity to -2 are solutions. In the second interval, pick a number between -2 and -1. So I'll pick x to be -3/2. And so maybe if I use the factored form this time, -3/2 minus 4, that's -3/2 minus 8/2, which is -11/2 in the numerator. And then in the denominator, one of the factors, -3/2 plus 2, that's just +1/2. And in the other factor, -3/2 plus 1, that's -1/2. And this number is negative. This just turns out to be, well, I'm sorry, I should not have said negative. It's positive because two negatives give us a positive number. So we just get negative or positive 22, and then the inequality less than or equal to 0 is false. So none of the numbers in that middle or that second interval are solutions. In the third interval, I'll pick x to be 0. That's the most convenient of all. In the original inequality, if you replace every x with 0, you're going to get -4 divided by 2, which is a negative number, and a negative number less than or equal to 0. That's true. So the numbers in the interval from -1 to 4 are solutions. And then finally, in the fourth interval, pick a number bigger than 4, like x equals 5. And I'll use the factored form this time. In the numerator, 5 minus 4 is 1. In the denominator, in this factor, 5 plus 2 is 7. In the other factor, 5 plus 1 is 6. So this is 1/42, and less than or equal to 0. That's false. So none of the numbers in the interval from 4 to infinity are solutions. And then we determine if the endpoints are included. Well, remember, any endpoint from the denominator is never included, so -2 is not part of the solution set. So we put a parenthesis at -2, and then we shade the interval to the left because from -infinity to -2, we have solutions. And then the other interval from -1 to 4, well, -1 is an endpoint that comes from the denominator, so it's excluded. 4 makes the numerator 0, and 0 less than or equal to 0 is true, so we do include the endpoint 4. And so the interval notation, I'll write that up here. The interval notation is from -infinity to -2, parenthesis, and then union, parenthesis, -1, comma 4, bracket. That's the solution written in interval notation.